Okay, what do all of these quantities have in common? 60 miles per hour, negative $40 per month, 0.44 psi per foot. Turns out they're all rates of change. What is a rate of change, you ask? A rate of change measures how much one quantity changes in relation to another quantity. And a rate of change is expressed using a ratio, one quantity in ratio to the other quantity. So 60 miles per hour, you could write that as 60 miles per means the division bar. Per is translated directly to division bar and then hour, HR for hour. 60 miles per hour. It's a ratio. It's describing how distance is changing per every 1 unit of time. In fact, you could write it as 60 miles per 1 hour, although that's understood to be true, that it's 60 miles per every 1 hour, so we don't write it that way. We just leave it like that. And that's a pretty familiar rate of change. Every time you look at your speedometer, you see your speed that you're driving at. The second rate of change, not as familiar. It's kind of weird. It has a negative $40 per month. It's not as strange as you might think. That could be how the amount of money in your bank account is changing per month. So the negative would just mean that the amount of money in your account is going down by $40 per month. You could write that as a ratio as well. Negative $40 and then division bar for per 1 month, MO for month. Now notice the first two quantities, the bottom values in the ratio, if you think of this as 60 over 1, it was the bottom quantity was measured in time, hours in fact, and then negative $40 per 1 month. The bottom number was also measured in time, months instead of hours, but it was measured in time. Here, this third quantity is a bit strange in that if you write it as a ratio, 0.44 psi stands for pounds per square inch. I'm just going to leave that as psi on top, and then that would be per foot, so division bar FT for foot. 0.44 psi, pounds per square inch, per foot. So the bottom value, if you think of it as 0.44 psi per 1 foot, it's not measured in time, but it's still a rate of change. It's still comparing, okay, what is this comparing? Where did I get this from? This is the approximate increase in pressure on your body measured in pounds per square inch per every 1 foot you go down in the ocean. And so it's still comparing two different quantities, the PSI, pounds per square inch, on top, and then feet on the bottom. So it's still a rate of change. So what does this have to do with what we're talking about today? Well, if you think about it, slope, which is defined as rise over run, is comparing the change in the rise units to the change in the run units. And so it is a rate of change, as we'll see in the next example. Okay, we have a graph on the left-hand side. Notice how the graph is labeled. It's labeled, the horizontal axis is in minutes. The vertical axis is in miles. And it says Amy's distance from home after running for 15 minutes and 60 minutes is plotted in the graph. So after 15 minutes, she went 2 miles. And then after 60 minutes, she went a total of 7. Find her average speed from the 15-minute mark to the 60-minute mark. Really, we're just going to find the slope between these 2 points. That will be the average speed. So code, this average speed is code for slope of the line between the 2 points. And when we put together the units, I'll show you why. But let's just go ahead and find the slope. So we'll call the slope the average speed. Now, you could use the picture or the slope formula. It doesn't really matter. Slope is rise over run, right? So I guess we could use the picture to find that. Okay, so from this point, how far up do you have to go to get to the same height as the other point? 1, 2, 3, 4, 5, or you could go 7 minus 2, 5. That's either one, right? So 5 up is the rise, and then how far over to get to the same horizontal position? 1, 2, 3, 4, 5, 6. Did I count right?
Yes, but it's...
No. What's wrong? Oh, yeah, we got to be careful and look at the units, right?
So it's 45.
So this is a situation where it would be easier to use the run formula x2 minus x1, right? Or just the difference between the x's. So what's the horizontal position of this point? 60. And then what's the horizontal position of this point? 15. Okay. So what does that turn out to be? 5 over 45, which we might as well reduce it. 1/9. Okay. Now we're going to change to a decimal in a second. But first, let's talk about units. I'm going to show you a trick that I wish somebody had told me. If you want to create the units of slope, you always just put the vertical axis units, usually y, but it doesn't have to be, in ratio to the horizontal axis units, usually x. Because think about it. What is slope? Rise over run. You put the rise units in ratio to the run units, and that gives you the units of slope. And then it also shows you why it's a rate of change. So 1/9, we'll change that to a decimal in a second. What would the units be?
1 mile every 9 minutes.
Well, yeah, you can think of it as 1/9 miles per minute, or 1 mile every 9 minutes. Yeah. Okay. So remember, the division bar means per. And so you can see the rate of change just fall out of it, right? 1/9 mile per minute. What if you wanted miles per hour? Anybody remember that conversion? Yeah, that one's not too bad just to figure out in your head, but let me show you a way of getting it where you'll never be confused again if it's a little more complicated than that. This is called unit analysis. It's really useful in chemistry and physics anytime you have to change units. So we have 1/9 miles per minute. Now, what do we want it in? We want it in miles per hour. The key to changing between units is realizing that units multiply and divide just like numbers. So if you want to switch to miles per hour, you want to cancel out the minutes, right? In favor of hours on the bottom. So you're going to multiply by the correct conversion factor that gives you minutes per some number of minutes per some number of hours. How did I know that? Let me erase that and make it look better. Again, because I want minutes to cancel, so it needs to be on top. I want hours to be on the bottom, so because I want miles per hour. So what is it? 60 minutes per 1 hour, right? Okay. Now you can see it happening, you guys. The minutes will cross-cancel just like numbers would, just like factors would, right? Doesn't work if there's an addition in between these things. And then you end up with what? You multiply straight across, what do you get on top? 60 miles per 9 hours, right? Or 69 miles per hour. Now, most people don't talk that way. Most people would put it in decimal form, wouldn't they? Or in this case, it might just be easier to change it to a mixed numeral. How many times does 9 go into 60 without going over? 0. You were thinking of the 6, right? Yes. Yeah. So 5 is 45, 6 is 54. So 6 times 9 is 54. What's 60 minus 54? 6. So you'd say 6. Well, okay, 6 and 6 9. Oh, remainder over divisor, except how would you simplify that? 6 and 3 goes into both the numerator and denominator here? 2/3. 2/3. So 6 and 2/3, which is 6.66, 6 repeated miles per hour. Okay? Again, The reason for this problem is emphasizing the slope as an average rate of change